Hello. Thank you for saying hi. So far, we have 12 participants. Today's class, 1 p.m. class, we're supposed to have 17. 17, we have 12. It's already 1 o'clock. I'm going to go ahead to mark attendance for today, all right? Let me take a glance. Angie, Ashlyn, Chloe, Cindy, Crystal, Jack Jackson, Jessica, Levy, Lexi, Molly, Reese. 12. We have Reese here, Jackson's here, Jessica's here, Molly's here. Cindy is here, awesome. This section, all are present. And this section, Emerson. Suddenly we lost one? Oh, still 12. Emerson absent. Alex. Excuse me. Excuse me. Alex is not here. Lexi is here. Emma. Emma is not here. Ashlyn's here. Jack is here. Oh, thank you. Thank you, Crystal. Angie's here. Jennifer, not here. Crystal is here. Charlie, excused. Chloe's here. Levy's here. Right? We don't have Alex, Emma, and Jennifer. Okay, I got everybody. Safe. Oh, hi, Alex. Could you email me? Then I can fix your attendance. I just saved the recording. Yeah, if that happens in the future, always please shoot me an email. We also have Alex. Emerson also join us. So please remember to email me. Yeah, please email me. I'll fix your attendance. All right. Today, we are going to start chapter 3. What do we do in chapter 3? We talk about logic, right? We might be able to cover the whole section 3.1 and some of section 3.2. So that's the plan. We start with the definition of statement. A statement is a sentence that is either true or false, but not simultaneously. That's the formal definition of a statement. Statement is a sentence either describes a fact or tells a lie, but not at the same time. Not at the same time. If the statement tells a truth, then we say the statement a true statement. And the truth value of the statement is T. Truth value is also a very important concept. If a statement tells a fact, states a fact, then that statement is a true statement. The true statement has truth value T. T is the initial of true, right? Let's see, we have a message. Hi, Emma. Please remember to email me if you missed the attendance earlier. Now I can fix your attendance. I don't really want to go back to do that right now, like in the middle of the teaching. Actually, we have 14 participants, but I feel like we are missing somebody. Emerson is still here. Alex is still here. Did we miss somebody? It was 12 or 15, actually. Number match. Okay. Yeah, where was I? Yeah, a statement is a sentence that is either true or false, but not simultaneously. If the statement states a fact, that statement is a true statement. A true statement has a truth value T. The capital letter T here is the initial of true statement. If a statement tells a lie, then the statement is a false statement. And the truth value of the false statement is F. F is the initial of the word false. So the statement is either a true statement telling a fact or a false statement telling a lie. It's not possible to be both. Okay, so that's the definition of a statement. We use lowercase letters P, Q, R, and so on with a notation. The symbols we use to denote statements is the lowercase letter P, Q, R, and so on. I think P, Q, R would be enough for us in this chapter. And we can look at some examples about statement. How about you guys help me to determine if the following sentence is a statement? Example, determine if the following sentences make a statement or not. Following a statement. Number 1, London is the capital city of England. Is this a statement? This is a sentence, right? Does this sentence give a fact or a lie? London is the capital city of England. It is a statement, right? It is, yeah, you guys are great. It tells a fact, so it is a statement. And the statement is true because we know London is the capital city of England, right? Very good. So the truth value of the statement is T. Next. This apple, this dish is delicious. D-E-L-I-T-I-O-U-S. No, C-I. Delicious. This dish is delicious. This is also a sentence. This dish is delicious, right? This dish is delicious. It is a sentence. Is this sentence give a statement? Does this sentence describes a fact or a lie? This one is a little bit difficult. I think it is, yes. So you see, some of them think it's a lie, some of you think it's a fact, right? This is an opinion. I would say this sentence gives an opinion. An opinion is not a statement. An opinion is not a statement. Because we know an opinion cannot be treated as a fact, right? You think this dish is delicious, maybe I don't think this is delicious. The dish is delicious. So an opinion is not considered as a statement. Opinion is not equal to fact or non-fact. Do you agree, guys? Yeah, thank you, Ashley. Is an opinion. Since an opinion cannot be considered as a fact or non-fact, an opinion is not a statement. All right, very good. Next. Betty Guo thinks this dish excuse me, is delicious. This sentence, Betty Guo thinks this dish is delicious. Very similar with the previous sentence, right? But it specifies a certain person, me, I think this dish is delicious. What do you think about this sentence? A statement or not statement? Is this also an opinion? For a specific person and a specific dish, either the person thinks it's delicious or not delicious, right? Even you guys don't know if I really like this dish, but it's either true or false, not simultaneously. Yeah, it is a statement, but it's not necessarily a true statement. No, it's not an opinion anymore. It is not an opinion. This is a statement. Because this sentence is either true or false. Either I think this dish is delicious, or I think this dish is not delicious. Right? Just to feel the difference between the second sentence and the third sentence. They're different. The second question, this sentence is really just an opinion. But this one states something that is either a fact or a non-fact. Do you guys agree? Do you see it? It is a statement. You know, when we determine if a statement, when we determine if a sentence is a statement, we really do not care about if the statement true or false. We don't care. Sometimes there's no way to know. What we need to focus on is the sentence give a fact or a lie. Perfect. Yeah, you get it now. Very good. You might not know my opinion about the dish, right? But my opinion, my feeling about the dish is either delicious or not delicious. So one or the other. So this is a statement. Next. Do not try to study in the dorms on Friday night or Friday nights. Friday nights. What do you think about this sentence? Do not try to study in the dorms on Friday nights. Do not try to study in the dorms at the Friday nights. Does this sentence give a fact or a lie? I would think this sentence not a statement. Yeah, Levy, I agree with what you typed here. It is not a lie though. It could be true because Friday night maybe is very noisy. People like to have parties in the dorms. So I would see this as a suggestion or a recommendation. Also, it's actually kind of an opinion, right, guys? This one is not a statement. Kind of like opinion, a suggestion. I recommend, or you can see that as a command, not very strong command, but kind of like a command. Yeah, do not do this, do not do this, or go to do this. A command is not a statement. Okay, a command is not a statement. Do you guys see it? Perfect. Okay, all right, awesome, very good. Next, number 5. Is it a good apple? Okay. This sentence gives a question. It is also a sentence, but this sentence is a question. It asks a question. Is this a good apple? What do you think? Is this sentence a statement? A question is not a statement because it does not give us a fact or lie, right? It just poses a question. So it's not a statement. Yes, very good. Perfect. Awesome. The last one. Go and exclamation mark. Exclamation mark. What do you think about this one? It's not a statement. This is really a command, right? Obviously a command. A command is not a statement. An order. Yeah, go to do this, go to do that. Or do not do this, do not do that. All right, guys, I believe you would have a pretty good understanding about what is a statement, right? A statement must either gives a fact or a lie. Cannot be both. Has to be very clearly state a fact or obviously a lie. And we don't really need to worry about the truth value of a statement as long as the sentence gives a fact or a lie, not simultaneously. And that sentence is a statement. All right. Of course, it's good that you understand what is truth value. T and F, truth values. And next up, we're going to learn a special type of statements. They are called quantified statements. Quantified statements. A quantified statement. This is a new concept. A quantified statement is a statement involves quantifiers. This is also new. What is quantifiers? Quantifiers are words like all, some, none, or no. So those are quantifiers. We call those words quantifiers. If a statement involves one or more of those quantifiers, we call that statement a quantified statement. Yeah, don't worry, we only have 4 types. We only have 4 types of a quantified statement. Let me give you the 4 types of quantified statement and also their corresponding Euler diagram. Today we also need to see, we're going to also see a type of diagram. It's called an Euler diagram. It's different from Venn diagram we learned in chapter 2. Euler is also the name of a mathematician. He was very productive. If you are interested, you can Wikipedia. He was very productive. I always think that, you know, in hundreds of years ago, even earlier, when people did not have TVs, they did not have internet or video games, they did not have the pop stars, and who do they look up to, right? I think those mathematicians, physicians, they are very knowledgeable and they are looked up to. So nowadays probably is very, you probably know a lot pop stars, but you probably do not know a lot famous mathematicians, right? It's just some thoughts. Okay, Euler, the pronunciation is Euler, not Euler. It's Germany. Euler diagram. Okay, so I'm gonna give you the 4 types quantified statement. The first type, all A R B. The corresponding Euler diagram is this. You might remember in chapter 2 we have learned the Venn diagram. In Venn diagram, we always have a box that represents the universal set, right? And then we use Venn diagram to study the connections between sets. And in the box, we use circles to represent the sets. And the difference between Euler diagram and Venn diagram is, in Euler diagram, we do not have boxes. We do not have universal set. So if you see the diagram without the boxes, Euler diagram. If you see the diagram has boxes representing universal set, that is a Venn diagram. Okay, so we use a Euler diagram to study statements. Of course, the statements involve sets. For example, this one, it involves 2 sets. So we have 2 circles. The circle A represents the set A, the circle B represents set B. And this statement says all A are B. For example, all women are human beings. That is a true statement, right? All women are human beings. That sentence is a true statement. It is correct. It's a fact. All women are human beings. And if I say all trees are apple trees, what do you think about that? All trees are apple trees. It is also a statement, but since it tells a lie, we know trees can have, besides apple trees, it could be maple trees, birch trees, tons of other type of trees, right? Of course, not all the trees are apple trees, so that is a false statement. So this is the first type of quantified statement. Quantified statement quantified statement involves 2 sets, and it gives a subset relationship. All A are B. The set of A is completely inside of set of B. That's the first type of quantified statement. Second one, no A are B. And the corresponding Euler diagram is, this is A, this is B. As you can see, the 2 sets AB are what? What we have learned, the concepts in chapter 2 in set theory are still useful in this chapter, because the quantified statement involves sets, right? It describes the relationship of 2 sets. In this case, the statement says no A are B. The 2 sets do not overlap. They are disjoint or mutually exclusive. No A are B. And that's the second type of quantified statement. No NO. NO here is a quantifier. None of A are B. There's no element in A that belong to B. There's no element in B that belong to A either. So that's the second type of a quantified statement. Next, some A are B. A little bit. Some A are B. It involves A and B two sets, right? So we have two circles. Besides the two circles, I have a dot. The dot appears in the overlapping region of the two sets. And this diagram, Euler diagram, represents the quantified statement, some A are B. I can give you an example. Let's say set A, all women or all female, right? All women or female. B, all teachers. Very simple example. Circle A represents all the women. Circle B represents all the teachers. And this statement says some women are teachers. Look at that. Betty. Here, this dot can be me, right? This dot can be me. Betty is a teacher. She is a woman. She's a teacher, right? Some women are teachers. Look at Betty is one example, right? So the dot appears in the overlapping part to stress the fact, not fact, I'm sorry, to stress the claim, to stress the claim that at least one member in A belongs to B, right? Do you see that? Do you understand the position, the location of the dot? Why it shows in the overlapping part of AB? Some A are B means at least one member of A belong to B, right? Some A are B. It means the same thing with at least one element in A belongs to B. So, for example, that element in A belongs to B. So this is the Euler diagram of this type of quantified statement. The last one, some A are not B. Some A are not B. So I also have two circles represent the two sets. Some A are not B. But this time, we also have a dot in the Euler diagram, but this time the dot does not appear in the overlapping part. Instead, it appears in circle A, but outside circle B, inside the circle A and outside circle B. Some A are not B is the same meaning with the claim that at least one member, one element in A does not belong to B, right? Do you see it? We can find some let's find some A are not B. Some A are not B. Okay, how about same with earlier? If we let A be the set of all women and B as the set of all teachers, then the statement says some women are not teachers, right? Maybe the dot is Emma, are you a teacher? Emma, are you a teacher? I just think of your name. I was trying to find the names. Are you there, Emma? How about Jennifer? How about Jennifer? Okay. Oh, okay. Emma, are you a teacher? You really are a teacher? Oh, no. Okay. So we can say the dot is Emma, right? Yeah, there are at least one woman who is not a teacher. Emma, for example, here. She's a woman, but she's not a teacher, right? Does that make sense? Yes, very good. Jennifer, oh, okay. So that doesn't work with Jennifer, but the dot here, the point here, does not work with Jennifer. It will work with Emma, right? And this one would work with Jennifer. Some A are B, some women are teachers. So this dot could be Jennifer as well, right? Okay. So I'm going to give you the equivalent way to describe the same quantified statement. I need you to try to memorize it. Okay, understand and memorize it. So all A are B. All A are B is pretty straightforward way to say this statement. But another equivalent way to say the same thing is there is capital letter. There's no A that is not B. What do you think? Do you think those two sentences means the same thing? Which two sentences? All A are B. Do you think all A are B actually means there's no A that is not B? Think about all women are human beings. All women are human beings. We know that is true, right? It's easier to understand if I give you a true statement. All women, an obvious fact. All women are human beings. Isn't that the same with there's no women that is not human being? Right, guys? Yeah, all women are human beings. It is equivalent to there's no women, there's no such a woman who's not a human being. Of course, this sentence is more complicated, but it really means the same thing. It just means all A are B. Agree, guys? Perfect. Awesome. Very good. Thank you for your response. And the second one, no A are B. An equivalent way to describe no A are B, okay, perfect, is all A are not B. Okay, to help you understand this equivalent statement for no A or B, I'm gonna use a Venn diagram. Okay, we are talking about Venn diagram, right? So Venn diagram helps us to study the relationship of sets. Let's say in the box, the universal set, we have two sets A, B. They are disjoint. No A or B, right? Disjoint. And which region, my question here is which region represent in the box, which region represent not B? I hope you remember what we just learned from chapter 2. Not B, the complement of B. The circle B represents set B. Which region represent not B? Think about it and tell me if you have the same same answer. I just used the blue color, shade a region in the box. Do you agree the blue region represent not B? That the elements in that region it belong to the universal set, but do not belong to B, right? That region actually represents not B, right? Perfect, yeah. And as you can see, if no A or B, then the whole set of A are inside the blue region. All A are not B. You see that? The whole set of A belong to the blue region. So all A are blue. All A are not B. The blue represents not B. And maybe this Venn diagram could help you to understand those two sentences means the same thing. Now, no A or B means all A are not B. All A are not B. Just one equivalent way to describe the statement, no A or B. Yeah, please let me know. Is that clear? The second quantified statement, no A or B. The second quantified statement, no A or B, is equivalent. One way to describe the same statement is all A are not B. All A are not B. I can show you if they are not disjoint, you will not have the circle A completely fall inside the blue. Okay, I can show you. If this is A, this is B. Those two sets are not disjoint, right? They overlap. And let me use the same color blue to represent not B. The region I'm highlighting in blue, outside circle B, inside the box, is not B. In the case AB not disjoint, in the case AB overlap, not disjoint, we do not have A completely, all A in not B, right? We do not have the set A completely in the blue. Only when AB disjoint, we have circle A completely fall in the blue, right? And maybe they would help you. These two Venn diagrams will help us to understand. No A or B is equivalent to all A are not B. Another way to say no A or B is not A. Is all A are not B. And don't worry, we're gonna have we're gonna have problems to help us to reinforce the meaning. Right now, we just try to understand the logic here. This chapter is about logic. Let's see if you have any questions. Okay, perfect. And the third one, some A or B. The equivalent way to say some A or B is at least there is at least one member of A also belong to B in B. One member of A. One element or element. Oops. Sorry. Element of A in B. Right? Yeah, at least one woman is a teacher. Me, I'm a woman teacher. Or Jennifer, right? Jennifer, the woman is a teacher. So at least one element of A belong to B. And similarly, some A are not B is the equivalent way to say that. To say some A are not B is at least one element of A not in B, right? For example, want to say some women are not teacher, right? Maybe they are lawyer, maybe they are housewives, maybe they are drivers, right? Nurses, yeah. So for example, Emma can be the one, at least the one woman who is not teacher, right? So we just need to get a one. Okay, so let's look at a table. Let me see, do I have the guided note downloaded? If not, let's download the notes from our course shell. Study the notes. We start chapter 3 right now. So we have 1, 2, 3, 4, 7, 8. And we have 6 sections. After those sections, we're gonna review for exam 1 and take exam 1. Just be aware, exam 1 gonna take place this month. Yeah, I'm gonna show you a table. Yeah, this table. This table gives the equivalent way to describe the 4 types of quantified statement. I want to show you the examples here. Give you some example that you can feel or reinforce what we understood earlier here. All right. First type, all A are B. First type of quantified statement, all A are B. There's no A that is not B, right? Earlier I gave you an example. All women are human beings. So there's no one woman who is not a human being, right? So the example in the table is all poets are writers. I would say, is it true or false really doesn't matter. But if you really want to make that decision, I think all poets are writers, right? They have to write poets. Okay, all poets are writers. Another way to say that is there's no one poet who is not a writer, right? There are no poets that are not writers. The grammar is not the most important thing. Logic is. Second type, no ARB. The order is a little bit different with mine. No ARB, right here. No ARB. Another way to describe no ARB, AB are disjoint, is all A are not B. For example, no math books have pictures. That's a false statement, right? But really doesn't matter. We really do not need to consider true or false. We are considering the equivalent way to describe the same statement. No math books have pictures. So an alternative way to describe that statement is all math books do not have pictures. Okay, if you are if your goal is to be a lawyer, if your goal is to be a lawyer or work on degree like a justice, legal system, and you're gonna pay attention to this, you need to pay attention to this chapter. Legal, that industry, the people must have good logic. Must have good logic. No math books have pictures. It doesn't matter if it's true or false. An equivalent way to describe the same meaning is all math books do not have pictures. Do not have pictures. Okay. Number 3, some A are B. At least one A, that is a B, right? So some people are arrogant. Yeah, that's a true statement. Some people are bigots. I'm not sure how to pronounce that. Some people are arrogant. So the equivalent way to say that is at least one person is arrogant, right? At least one. The last one, some A are not B, the last row. The equivalent way to describe the statement is not all A are B, not all A are B, or at least one A is not B, right? Not all A are B. Yeah, not all A are B. Some students do not work hard. Not all students work hard. They mean the same thing. Not all A are B. So I can fix that, or not all A are B. Not all A are B. So we actually have two equivalent ways to describe the fourth quantified statement. All the three sentences means the same thing. Some A are not B. At least the one element of A does not belong to B. Or say, not all A are B, right? Not all A are B. Okay. So that's about equivalent ways to describe the same quantified statement. Next concept, we want to talk about negation. Negation. We can go back here actually. No. We have already learned what is statement. Say P is a statement. This notation, not P, a wiggling, the wave, and in front of P is a statement. This notation also represent a statement, and it is the negation of statement P. The negation of statement P is denoted as a wave P. You can call this not P. You can call not P. Not P negates P. Let's give you a very simple example. If P says it is raining, do you agree it is raining a statement? The statement is false right now, right? So outside is either raining or not raining. So it is a statement, either true or false. So P is not raining. Then what is not P? The statement that negates P. It is not raining. Right? It is not raining. Very simple, right? Knowing negation is a mutual relationship. If not P is the negation of P, then P is also the negation of not P. In other words, P and not P, P and with P, they are negation of each other. They are negation of each other. All right. This is also very similar with set A and set A prime. This means not A. Not exactly the same thing, but similar idea. Similar idea. And now we want to look at, so we understand what is negation, right? We understand the notation of negation. Now we want to go back the 4 quantified statement and look at the black sentences, not the red one. Look at the black sentences. All A are B, no A are B, some A are B, some A are not B. Look at those 4 types of quantified statement. We want to find their negations. Okay, we want to find their negations. In fact, the negation of a quantified statement is also a quantified statement. So that means, for example, all A are B. One of the 4 is going to be its negation. Yeah, think about. So I'm going to label them, okay? Just label them. This one, first type, second type, 3. This is my order, 4. The order really doesn't matter, okay? Just the 4 types of quantified statement. Which two of the 4 statements are negation of each other? How about let's start from all A are B. What's the negation of all A are B? All women are human beings. Think about that. How do you negate all women are human beings? Well, there are multiple ways to negate it. But can you use one of the 4 statements here in black to find the negation of all A are B? All women are human beings. What's the negation? All women are human beings. One common mistake is to mistake number 2 as the negation of number 1, which is incorrect. Okay, if you wanted to say that, do not say that because it's not correct. No A are B is not negation of all A are B, okay? Yeah, let's think about which one is the negation of all A are B. All A are B. All A are B. Not all A are B. At least one element of A not in B. So what do you think? What do you think? What's the negation of all A are B? Are you guys here? It might be harder to negate a true statement. Some A are not B. Exactly. Thank you, Ashlyn. You got it right. Some A are not. Okay, let me get it right as well. Perfect. Exactly. We agree on those 2 are negation of each other. Negation of each other. The negation of all A or B is not A or B. Okay, all trees are maple trees. Okay, if we give a false statement, probably it's easier to find its negation, right? It's hard, to be honest, it's hard to negate a fact. At least that's my feelings. So what if all A or B describes all trees are maple trees? You probably right away would say, no, not all trees are maple trees, right? Apple trees not. At least the one tree I can figure out, I can tell you, apple tree in my backyard is not maple tree, right? Yeah, so all A are B and some A are not B. Those 4 quantified statements are negation of each other. Yeah. understand and memorize. If you want to have a good score on exam 1, you need to memorize, you need to understand and memorize. I'm not able to memorize anything if I do not understand the thing first. Understand and memorize. Practice. When you work on your MyLab math, you can refer to here, right? All A are B, and some A are not B. Those two quantified statements are negations of each other. That leaves us the other two. The other two also negation of each other. No A or B, no A or B has negation some A or B, right? No men are good. So some women probably don't have good experience with dating. So no men are good. And maybe your friend would say, some men are good, right? Just keep looking. Some men are good. So the negation of no A or B is some A or B. Do you see it, guys? So I cross this. Yeah, number 1, number 4, they are negation. Number 2, number 3, they are negation of each other, right? Perfect. Let's look at an example. This example has 2 parts. We are given a statement. We need to find an equivalent way to describe the statement. That's part A. In part B, we need to write the negation of the statement. So we can read the question. For each exercise, part A, express the quantified statement in an equivalent way. That is, in a way that has exactly the same meaning. Part B, we need to write the negation of the quantified statement. The negation should begin with all, some, or no. Yeah. Okay, so let's see. Our first statement says all journalists are writers. I give you a little bit of time. You look at the notes. I hope you're taking notes. And see how do you answer the problem. And then you compare your answer with mine. Okay? All journalists are writers. All journalists are writers. The equivalent way, part A is the equivalent way. Part B is a negation. I'll give you a little time to think about it. How do we write exactly the same thing a different way? All journalists are writers. If you look at the table here, an equivalent way for all A or B is there's no A that are not B, right? And what is the negation of that? The negation of all A or B negation of all A or B some A are not B, right? All A are B, some A are not. And those are negation. Those two are negation of each other, and those two are negation of each other. Negation. Yeah, look at the table one more time. Maybe you can take a screenshot and then try to answer this problem. Let's see if you agree what I answered here. All journalists are writers. There isn't one journalist is not a writer. You know, I do not think about true or false. It really, to be honest, is unrelated. The purpose, the goal here is not determining true or false, determining the fact or not. Is to find a different way to say the same thing. All journalists are writers can be rewritten as there isn't one journalist who is not a writer. Yeah, the grammar is not really matter. Who is not a writer, right? That's an equivalent way to describe that. Negation. all journalists are writers. You can say not all journalists are writers. You can also say some, or at least one. You can say some journalists. Yes, it says begin with all or some or no. So some journalists are not writers, right? Do you agree what I wrote here? Could we write it as yes, Levy? I'm waiting for you to type your answer. All journalists in part A, all journalists are writers. Yeah, then that is the given statement. That would be the same, exactly the same wording with the statement. Part A is to find a different way to say the same thing. The wording cannot be exactly the same. Did I answer your question? All journalists are writers. That is the original given statement. I mean the other way. The other way is there isn't one journalist who is not a writer. Those two ways are the same meaning. I don't quite understand your question, Levy. You mean negation? Sorry, I'm gonna. Maybe you can email me with the question if you want.
Yes, what I was going to say is instead of writing it as all journalists are writers, to switch it as all writers are journalists.
Oh, no, that's not the same thing. Okay, I got you now. Okay, that's a very good question actually, but they mean different things. So, if circle A represent what's going on here? Yeah, if circle A represent the journalists, and the circle B represent writers, this Euler diagram describes all journalists are writers, right? The circle of journalists completely fall inside of the circle of writers. But if we consider this sentence, all writers are journalists, then the Euler diagram is going to be like this. This is writers. This is B. And this is A. This says journalists. This one means A is a subset of B. This one B is a subset of A. They completely different. They are very, very different. They are not equivalent at all, and they are not negation of each other either. Even they are different, but they are not negation of each other either. They're just two different statements. It's just like all women are human beings. You're trying to say all human beings are women, right? They are definitely not equivalent, because if two statements are equivalent, they should have the same truth values. But all women are human beings is true. All human beings are women is false. Did I answer your question? But this is a good way to, that's a very good question. The statement we are given is circle A is inside the circle B. But if we swap writers and journalists, we will have a circle B inside circle A. We will have a totally different statement, which is not equivalent with the original. It's not a negation of the original either. Levi, did I answer your question? Okay, thank you for, that's a very good question, by the way. It is a very good question. Okay, next problem. Some movies are comedians. Let me adjust the spacing here. Okay, some movies are comedians. Okay, this one I highlight in red. That's the given statement. Okay, some movies are comedies, not comedians. My bad. Comedies. Some movies are comedies. So the part A is the equivalent way. Part B is negation. Okay, let's find an equivalent way to describe some movies are comedies. I can say there is at least one movie that is a comedy. There's at least one movie that is a comedy. They mean the same thing, right? Some movies are comedies. Yeah, it itself is a true statement for sure. A true statement is easier to find the equivalent, and a false statement is easier to find the negation. Some movies are comedies. It means the same ways. There's at least one movie that is a comedy. And a negation, how do we negate? Some movies are comedies. What do you think? Some A or B. What's the negation of some A or B? No movies are comedies. No movies are comedies, right? Do you agree, guys? Awesome, very good, perfect. You guys doing great. So today, yeah, so we actually basically finished section 1. I'm gonna type the name of the concepts we went over so far, and you ask yourself, am I clear about the definition? The first concept, statement. Statement. Do you know what is a statement? What is the truth value of a statement? Right? What is a true statement? What is a false statement? What is the negation of a statement? And what is the notation for negation? Right? Yeah. Do you understand, or are you clear about the concepts of those things? And also we learned what are the 4 types of quantified statements. Okay, the first one, all A are B. Yeah, what's the equivalent? What's its equivalent? What's its negation? No A are B. That's the second type. Some A are B. Some A are not B. Right? Those are 4 quantified statements. We're gonna use them, and also the Euler diagram again in future sections in the same chapter. All right. Okay, we have 15 minutes. We're gonna start section 2.1. Sorry, 3.2. 3.2. We're gonna start section 3.2. What do we do in section 3.2? we're going to talk about compound statements. In order to know what is a compound statement, we want to know what is a simple statement. Simple statement is a statement states a simple idea. It gives a fact or a lie is a simple idea. So that is a simple statement. If a statement includes two or more simple statements and also logic connectives to connect those statements, we call the statement a compound statement. And what is the logic connectives? We have already learned a connective. Technically, it's not because it only involves one statement, but for convenience, we're gonna just talk about them all together, okay? Yeah, we are going to learn some symbols. We are going to learn some symbols, very important. That's the first symbol. And then we're gonna learn this one, this one, this one, and this one. And the rest of the chapter, we are going to deal with those symbols a lot. 1, 2, 3, 4, 5. And this notation, for example, not P, okay, represent the negation is called a not P. It's called not P. Represent the negation of a statement, right? If we have a statement and you put a wave in front of the statement, you got a negation of that statement. And this notation, like a small v, right side up v, means, yeah, for example, we have connects two statements, gives us a disjunction. You start to know new things. It's like when you watch a movie or not movie, a show, very long show. At a certain point, I start having new characters throughout, right? You're gonna know the names of those characters. So this notation means disjunction. It actually means or, P or Q. It is pretty consistent with the notation we learned in chapter 2, set theory. In set theory, how do we describe A or B? A, right side up U, right? Right side up U, A or B. And similarly, we use a right side up little v, it also opens upward to represent the or. The or here is an inclusive or. P or Q is denoted as P, you know, this notation, and the Q, right? P or Q. P or Q is a disjunction. That's the name, disjunction. A or B or P or Q. And you might remember in set theory, the upside down U means and, right? Here is the same. Right side up V is or, and the right side up V is flip it, and we got an and. So P and Q. This means P and Q. P and Q gives a conjunction. And maybe the first time the name just feels so strange. You will get familiar with them. After this chapter, you should be an expert, you know, knowing the concepts. Disjunction, conjunction, we're going to use them over and over. And then the other two, I don't think we have time to talk about it. Just to know this is a conditional. And this double arrowhead is biconditional. Right, biconditional. So today, the rest of 9 minutes, we can maybe talk about a little bit disjunction and conjunction. Disjunction and conjunction. We understand negation. Disjunction P or Q. All right, P or Q. Conjunction P and Q. It's just a notation. It's just notation. Let's look at some problems. Just remember disjunction refers to P or Q. The logic connective that represents or is a right side up little v. The upside down little v represents a conjunction. It is and in logic. This notation means and in logic. Okay, let's look at some problems. I downloaded 3.2, I believe. 3.2, yeah. Let's look at some problems. When we use logic, sometimes try not to struggle with the true or false. Otherwise, so be very clear what's your goal in this problem. When you do not need to worry about the truth value, do not do that. Otherwise, you drive yourself crazy. Okay, try this one. P states I study. Q states I pass the course. Write common statements in symbolic form. This sentence says I study or I pass the course. This one is very simple, right? You just write. So as you can see, you need to be able to analyze the structure of the sentence. I study or I pass the course, right? So the logic connective here is OR. OR is this right side up V, right? I study P. I pass the course Q. So it's just P or Q. Next, I study or I do not pass the course. So we do have a disjunction here. So we have a little v here. To the right, to the left of the notation, the logic connective is P, I study, or I do not pass the course. So do not pass the course is the negation of Q, right? So you're going to have not Q. You do not have to have the parentheses, but with the parentheses, make it look better and it's still correct. So the second sentence can be written as P or not Q. So whenever you talk about disjunction, whenever you talk about disjunction, you're going to know that disjunction connects two pieces. Sometimes the two pieces are simple, sometimes very complicated. So that's the reason I don't really say this simple statement, that simple statement, because it has two words and more complicated. I'll just say there's two pieces. There are two pieces, P-I-E-C-E. There are two pieces involved in a disjunction. This is the piece, and this is another piece, right? And the disjunction connective is in the middle. In this case, number 2, I study or I do not pass. Yeah. Again, do not worry about the meaning. If you worry about the meaning, you yourself crazy. What is that? I study or I do not pass the. Yeah. Okay. Actually, that actually makes sense. I study or I do not pass the course. Yeah. But this is inclusive or. I study or I pass the course. So it doesn't really make sense. Some of the common statement really does not make sense. So do not struggle with the meanings. Focus on the logic part. So I would say this disjunction has two pieces, the blue piece and the green piece. That's the way I describe a disjunction. Okay, let's continue. Let's do conjunction. Here, P, I'm leaving. Q, you are staying. How do we write a given common statement in English in their symbolic form, equivalent symbolic form? I'm leaving and. So when you see and, that is a conjunction, right? Conjunction also connects two pieces. First piece, I'm leaving. Okay, that's P. Second piece, you're staying. That is Q. So it's just P and Q. Next, you're staying and I'm not leaving, right? So since it's and, we have a conjunction. The conjunction here, the connective, gonna connect two pieces. First piece, you are staying, so that is Q. You are staying is Q. Second piece, yeah, one piece on the left, the other piece on the right. I'm not leaving. I'm leaving is P. I'm not leaving is not P. Right? So that's how do we go from English sentences to symbolic form. Next, we are going to do the other way around. We are going to write the symbolic form. Yeah, we will be given. Let me find the problem. We'll be given symbolic form, and we're going to translate them back into English sentence. This one, okay. We have 3 minutes, should be enough. In this case, we have two simple statements. P says Romeo loves Juliet. Q says Juliet loves Romeo. And this statement, this symbolic form, we need to know the structure, okay? This negation notation negates whatever inside the parentheses. It does not only negate the P, it negates the whole thing inside the parentheses. That's why we have a parenthesis which is a grouping symbol to frame P or Q, right? Then how do we translate something like that? We can say it is not true that. So the negation here, the negation symbol, I can just translate it to it is not true that. What is not true? Whatever inside the parentheses is not true. What is that? It is not true that Romeo loves Juliet or Juliet loves Romeo. It is not true that Romeo loves Juliet or Juliet loves Romeo, right? So English-wise, grammar-wise is also very neat. Do you agree, guys? I need some responses. The negation here, we need to know the negation here negates the whole thing inside the parentheses. Okay, perfect. And what about the next one? This notation. This in this expression, the negation only apply to Q. Yeah, this negation is with Q. So I can also write this as not Q. The negation is with Q. Okay, has nothing to do with and the P. Okay, so look at the structure. We have a conjunction. The conjunction has two pieces, the green piece and the purple piece. Okay, and how do we translate that? We can say not Q. Q says Julia loves Romeo. Then the negation of Q would be Julia does not loves Romeo. But I could see and, right? I could see and. Okay, if we use and the P, the purple one, purple said Romeo loves Juliet. And is the supposed the translation of the conjunction, but sometimes we translate it as but is more natural. Juliet does not love Romeo, however, or but Romeo loves Juliet. It still means conjunction. Still means conjunction. Instead of and, use but is better. Use but is better. Okay, last one. Last one, the structure of this expression is not P, one piece, disjunct Q. The disjunction has two pieces, the yellow and pink, right? Disjunction also have two pieces. The yellow one on the left, first piece, second piece, the pink. So how do we translate that? Not P. P says Romeo loves Juliet. So not P is Romeo does not love Juliet, or Q, Juliet loves Romeo. Juliet loves Romeo. Yeah, as I said, do not worry about the meaning. Sometimes if you struggle, sometimes it just make you feel crazy if you try to figure out what does that even mean. Romeo does not love Juliet, or Juliet loves Romeo. What does that even mean? It's not the focus of this question. This question is to translate the statement from the symbolic form to a English sentence. All right. Okay, guys, we're gonna stop here, and we're gonna talk more about section 3.2 on Wednesday. Again, if you missed the roll call, please email me. And also, I hope you could maybe get into the meeting 1 or 2 minutes earlier. Then I don't have to always spend time to fix your attendance. I really appreciate that if you can join the meeting on time. Thank you so much, guys. I'll see you on Wednesday. I'll see Essential. Angie, I'll see you in 10 minutes. I'll see Essential at 2:30. At 2:30. Okay, guys. Bye bye. See you soon.